All right. Well, hello everyone. I just wanted to talk about HLM or hierarchical linear modeling, also known as multi-level modeling. And my name is Dr. Tiberio Garza. I'm at Florida International University in Miami, Florida. And thank you, Dr. McNaughton, for letting me present on this topic. So just to get started, right, you see this image here. This is the idea of just generally HLM has levels, or nested is another term as well. Whenever we think about statistical analysis, we think about the data structure. And so having structure to the data will then make us think about the use of HLM in our analysis. And so imagine trying to study student success while ignoring school funding differences. That's going to be like, as I say here, studying fish while ignoring the water quality. And so HLM is going to help us examine these layered realities by explicitly modeling the fact that students are grouped within schools, right? And then schools are often grouped within districts or states, right? So again, it's the idea of nested or just the layered realities. So what this means is that students within the same school might share certain experiences or resources, like the quality of teachers, class sizes, or again, like things like extracurricular opportunities. And so that will set them apart from students or other schools, right? Again, think about even things like socioeconomic status in different schools. Again, just making it just relatable to us, classroom sizes, or just any programs or activities within schools. And so when we think about the students' experiences, recognize it can vary across schools. And so based on the school's resources, we want to incorporate that into our statistical analysis. If we only use traditional statistical methods, which might be like regression, then what happens is we ignore this grouping idea, or again, this nested idea. So we'd risk drawing misleading conclusions because we'd be treating all students as if they were entirely independent from one another. In other words, regular regression pretends all students are islanders, right? So to speak, they're separate, while HLM knows that they're neighbors in the same town, right? So again, just helping you see the difference there. But again, we mentioned HLM, same thing as multi-level modeling. So it lets us account for these nested structures, and it allows us to study how these factors at each level, like individual student characteristics, school resources, and district policies, work together to influence outcomes. So in other words, HLM helps us understand not just how individual students succeed, but how the environment they're part of contribute to or hinder their academic success. Right. And so again, I'll just be scrolling down. I made this PDF as a PowerPoint just to help with visuals, but I'll provide this as well as provide a script as well to help just you learn more about HLM and know how to apply it, especially in Stata. So again, just visually, the core concepts of HLM, right? So recognizing we have our student level factors and school level or teacher level, whatever the second level is. Sometimes some researchers will use time as a level as well. So time-based factors and with student factors. Here, I just want to talk about two level, but you can get more complex with three levels or more. Some of our statistical techniques can handle three level. I don't know about four level and five level, but it gets very complex. But remember, in statistics, we want to use the idea of parsimony. So why have five, six, eight, 10 levels when you can actually think about it in two levels or three levels? I think we can go into four and five levels, but it gets very complex and sophisticated. And I'm not sure if Stata can do that. But again, right, if you're interested in four or five levels, find out if Stata can handle that. It might be that you might have to go to R, and it might be that little is known about multiple realities like that. And so again, just the core concepts, again, right, level one, level two, and this idea of cross-level effects between the levels. And so in this example, right, we see some study habits, socioeconomic status, and then we look at teacher-student ratio, school resources, and then at the cross-level interaction, we might think about things like how school budgets might amplify or mitigate individual disadvantages or advantages. Right, so again, it's the cross-level effect there. But just to give you an example, right, let's say a student's access to tutoring, right, which would be in level one, matters more in schools with better funded libraries, right? Better funded libraries against school resources, that would be level two. Right, if we were looking at something like that, regular regression would miss this interaction effect unless, right, if you really are into regression, if we knew that, we would turn that interaction into an actual variable for our regression. But again, sometimes we're not aware of that. But generally, regular regression would miss this interaction. But HLM reveals these layered realities. Again, regression assumes independence, but HLM is going to account for that nested or shared group influence. And that's really the core idea of HLM. So if you feel like the data has these layered realities or these nested perspectives um, and you want to know the effect across these levels, then this is going to be the reason why you want to use HLM. And so I just wanted to just help with just the Stata implementation or just thinking about the Stata coding as well. And so we're going to exhibit this level one, level two as well within Stata. And so in this example, using the command mix math scores SES, and then the rest of this, again, I'll provide a script that shows all this in the code if you're trying to follow. And as well, since I'm kind of cutting the code apart, but at the end, I'll give you, or within a script, I'll give you the whole code. That way you can see it all together. And so here in this part, the first part right here on this math, right, we're going to predict math scores using social economic status. And then the next part on the student school ID, this accounts for the school differences, right? So like which school a student attends. So it's important to have the ID aspect. The next part is related to estimation, REML. It's restricted maximum likelihood estimation. You can change the estimation, but for now, we'll use the most likely default estimation method. But it's just a statistical method that's well suited for this nested characteristic of the data. And here you don't have to add this, but I added the variance. The variance is just to incorporate the covariance as well. But again, my script will have some notes for some of this. And so basically through this code, this one line code right here, we want to know, right, this predicts math scores using SES while accounting for school differences. And so some things we'll get out of this is the average impact of SES across all schools. And then on another thing will be how much schools vary around that average, right? So it's like around that average and then the impact across all schools. So some tips to when you're thinking through this or just tips for beginners. We can think about starting this as an empty model. And so by an empty model, what we're trying to say is just that um, this part right here, right? So notice that part. We want to see, this is going to answer how much do math scores vary between schools versus within schools. And so it's helpful to just kind of see this empty model or this first model just to see um, what the results look like and some considerations. And then after that, right, you can do some visualization of that empty model using margins. And of course, after adding this, then the margins plot to kind of see the visual aspect of that. But one key thing that we need to incorporate about when or when to use multi-level modeling is something called ICC. And this stands for the interclass correlation. And so this specific measure that we can get out of Stata or any statistical software, we ask it by using this command, right? estat-icc. And so a benchmark to go off with this, like first off, like what is ICC, right? So I put helps us determine what percentage of the differences in student outcomes can be attributed to which school they attend rather than individual factors, right? So if that ICC value is less than 5%, then we're going to conclude schools don't matter much for this outcome, right? That meaning that, yeah, schools are generally consistently uh, the same, right? All the schools are working the same, and we might want that. And so, but if the schools are not working all the same, the schools have funding differences that are influencing student outcomes, right? Then that's when we want to use HLM. And so we're making that decision based on the ICC value. And so if it's greater than 0.05, again, these will be in the results of your Stata code. So if it's more than 5% of differences come from the school level factors, then we'll recognize, right, schools play an important role. And this is going to mean making HLM necessary, right, or needed, very needed. So again, this would be our quantitative way through ICC to verify if we need to use HLM, right? So again, code is just that simply, but again, I'll have a script that helps you kind of see all the code together. And so just going through this, just another example, making sure we're connecting everything together. Um, as you run the model, again, mix math scores, SES, right? And then we have our ID and then our estimator. We'll get our outputs, right? And then we're really looking at this ICC value. And so the way we would see kind of the results of this is each $1,000 increase in SES predicts a 3.2 point increase in math scores just based on our coefficient values here. And then the idea of 18% of score differences stem from school level factors, right? So but right, recognize if we go back to this slide, right? If we go use our 0.05 greater than or less than for ICC, this 0.18 is going to conclude and help us determine that, yes, you know what? There is a difference between the schools at the school level for these individuals. And so for that reason, HLM is necessary. And so again, I want to stress this is like the deciding factor when we need to use HLM, right? So that we would definitely this would confirm the use of HLM. And so just some other things, troubleshooting and completing your Stata workflow, right? Again, just illustrating some major pieces of code we would use. Again, we want to verify nesting, right? That again, the data is like correctly uh, connected with student ID and school IDs, and then running the model, right? But I recommend running an empty model first, and then visualizing results, and then confirming, right? Confirming that HLM was necessary. Let's see. That's at the end of this slide, but just to give you a simple analogy again, just to try to hit it home and reinforce, right? I'll give you a baking analogy. Imagine you're baking cookies in different ovens, right? And these ovens could be schools. If all ovens bake the same, the cookie differences are just about the dough, right? The students, right? Students would be the dough. Um, so in some ovens, if some ovens run hot, right, hotter than others, and some run cold or colder than others, the oven or the school, uh, or just would just focus on the dough or really with the student outcomes. Recognize it's great if we have consistency across schools because then we can predict the same outcomes across all students within all schools, but it is very likely that schools have different resources, different pedagogical ideas, different things, right? Think of it as a policy level, right? And so if I already know that there are differences, it may be that the probability of using HLM is probably appropriate. But again, the ICC is the deciding factor in that. I believe we can conceptually think schools are probably different, but again, the ICC plays an important role in that process in confirming that. But again, that's just the brief intro to HLM, when to use it, why to use it, and the ICC will be key to confirming that it is appropriate to use. But I hope that was helpful. And again, I'll provide these slides as well as a script that I went off to just kind of guide me through. And in the script and in this PowerPoint, there'll be some helpful explanations and comments and code to help you on your start to using HLM. Well, thank you and bye for now and take care.